The next section we're going to look at is symmetry with polar coordinates. And as a quick review, when we look back at rectangular coordinates, we did something like this. If I had a point that was in the first quadrant, we called that xy, and I wanted to reflect that across the y-axis, we represented that coordinate as negative xy. Or if I wanted to reflect across the x-axis, if I had the point xy, an x-axis reflection would yield the point negative xy. We want to use the same approach looking at polar axis, the theta equals pi over 2 line, and the pole. But remember, with polar coordinates, there's multiple ways that we can represent each point. So I just want to visually explain that to you, and then the next video I'll go into the lesson with a quick summary of this thought process and then going through a couple of problems. But if I put together my coordinate plane, and let's say I've got an ordered pair in the first quadrant here. We're going to call this r theta. The first type of symmetry I like to look at is across the polar axis. And the polar axis is this line right here. We've called that the x-axis in rectangular coordinates. So if that's the case, I want to find the ordered pair that is right there. Now, there's a couple of ways that I can get to that point. The first way I could get to that point is going in the clockwise direction and then walking outward. So if I look at it from that perspective, if I go in the clockwise direction, I'm facing this direction, then walking straight out means I'm going to have a positive r value. This value here is going to be negative theta, so I could represent that ordered pair as r negative theta. So for a graph in polar coordinates that's reflected across the polar axis, I have to say for every r theta, r negative theta is on it. But we also know we can represent this exact same point with a negative distance. And if we do that, that means I've got to be facing in this direction, looking outward there, and then I walk backwards in order to figure out what that negative distance is. So if I need to know what this angle measurement is, I know that this angle here is theta, this we know is pi, so the entire angle measurement to get there is pi minus theta. So if I wanted to write this point in terms of a negative r value, I could say that's negative r and then pi minus theta, because then I'd be facing this dotted line here, but since my point is behind me, I've got to have a negative r to get there. So that's the first type of symmetry, the polar axis symmetry. The second type of symmetry we want to look at is one that is across the y-axis, or in polar coordinates, it's theta equals pi over 2. So let's say I've got a point in the first quadrant that is r theta. If I'm going to have a reflection across the y-axis, or the theta equals pi over 2 axis, that means I'm looking at the point over here. And if I want to write that point in terms of a positive r and a negative r, there's a couple things I need to take into account. First thing is, let's go down here. If I walk in this direction, or put my angle in that direction, I've got a negative theta. So I'm facing this direction with the negative theta measurement. For me to get back then to this r value, I've got to go backwards. So this ordered pair would be negative r, negative theta. If I first go in the direction of a clockwise angle movement, I then have to go backwards, which is a negative distance, to find that r value. So r theta, every point, if I've got a reflection over theta equals pi over 2, negative r, negative theta also has to be on that point, or on the graph. The other way I could look at it is from the positive r value. Once again, I know that this angle measurement is going to be theta, and this is pi. So if I measure from the polar axis all the way to that line, that means I'm now facing in this direction, and I'm going to go a positive distance out. And that positive distance out would be r, and the angle measurement is, this is theta before pi. So pi minus theta. So there's a second way that we can look at symmetry across the line theta equals pi over 2. For every r theta, negative r negative theta is going to be on the graph, and for every r theta, r and pi minus theta is going to be on the graph. The last type I want to look at is then across the pole. And you know the pole as being the origin. So if I've got the point r theta, that means I need to get this point to also be on the graph. And there's multiple ways that I can write this one as well. The easiest way is just to go backwards and take the negative distance from this angle that I've already got. So if this angle here is theta, that means I'm facing this direction. I'm just going to walk backwards, and I'm going to have negative r theta. The other way that I could look at it is from the positive distance. And if I look at it from the positive distance, that means I've got to be facing this line going outward. So that means my angle measurement is this direction. So then I would have r, because I'm walking out, and then this is pi. That angle is theta. So then I would have pi plus theta for me to get to the point out there. So to summarize these different relationships, if I have a reflection across the polar axis, that means for every r theta on the graph, we also need to have the point r negative theta, or we could write it as negative r pi minus theta. The polar axis, once again, is like the x-axis reflection. We then looked at the reflection across the line theta equals pi over 2, the y-axis reflection. And then for every r theta, that would mean that negative r negative theta needs to be on the graph. Or if I want to look at it from the positive r perspective, r pi minus theta needs to be on the graph. And then finally, if I'm looking at symmetry around the pole, that means for every r theta, negative r theta also has to be on the graph. Or writing from the perspective of a positive r, r and pi plus theta.